Okay, so here we have four main files to start our calculations and let me start with POSCAR file, which just have information about positions of atoms in unit cell. Well, each crystal contains unit cells that can be multiplied and translated some amount of times, and yeah, let's say here. So here is a crystal lattice. Well, in terms of centimeters, it will contain, I don't know, maybe 1 billion of such unit cells. And all you need in quantum mechanics simulations is set up correctly that unit cell. And if you have correct unit cell, you will be able to generalize all of the information that you can uh, figure out from that unit cell to the whole crystal, because the whole crystal um, contains all that unit cells. And uh, well, having boundary conditions on the edge of that unit cell, uh, you will be able to place here, for example, another unit cell, and by and let's say um, eigenvalue in that point will be equal to eigenvalue in that point and in that point and so on. That's how WASP works, and having those boundary conditions, uh, WASP just multiplies. WASP thinks that and generalizes all of the calculations to infinite number of unit cells. So it just actually it makes calculations only for that unit cell, but the information is applicable to the whole crystal. And where to find out such unit cell, let's say, for example, for silicon. You can find out that information in crystallography open database website, and let's search from the beginning. Okay, so silicon, and we have only one type of uh, element in our unit cell, and yeah, number of distinct elements is equal to 1. And let's have a look on that. Oh no. Let's have a look on that crystallography information file, and we can visualize the unit cell that file using Vesta software. And let me just visualize it using the software. Well, don't worry about that bounds, and we'll delete them. And yeah, here we are. Uh, well, if you can see, the positions of atoms here is so equal to what we have right here. And well, we found out appropriate crystallographic information file, CIF file, and we want to export that positions that file into VASP type. And let's let it be the silicon.wasp file. Okay, and yeah, here it is. And we can do that again, and again we have the same bonds and the same unit cell. We also can rename it into POSCAR file, and that will be that is how POSCAR file looks, and it doesn't have any uh, type of file. It is just POSCAR file, like just a notepad file. And yeah, so here we have bases of that unit cell and position of 8 atoms that located into that unit cell. And yeah, that's pretty enough. And next we have 3 other types of file, and I will describe them to you later. And also I will show how you can upload your files into a supercomputer just in the further videos.